Today we are doing lesson 5.2, proportions. Our I can statement for today, I can determine if two ratios form a proportion. So for our key idea here, proportions, a proportion is an equation stating that two ratios are equivalent, which means equal. Two quantities that form a proportion are proportional. So when we read this proportion, it looks like 2/3 equals 4/6, but really it's 2 is to 3 as 4 is to 6. It's comparing two ratios and saying they're the same. So some properties of proportional relationships if things are proportional. One quantity is a multiple of the other. That means if you multiply the first thing times 2, the second thing will also get multiplied by 2. If the first quantity is 0, the other quantity is 0. If you double one quantity, the other doubles as well. And then cross products of any two ratios are equal if they're proportional. So in our lesson today, we're going to be looking at a couple different strategies for how to see if ratios are proportional. Okay, so for our first one here, tell whether 6:4 and 8:12 form a proportion. So here's what we're seeing. 6/4, if we think about it as a fraction here, is that going to equal 8/12? Okay, so there are a lot of different ways to check. One is to look for multiplication patterns. They're not always going to be a whole number that you multiply to get from one to another, but on this one I can see on the bottom there is 4 times 3 equals 12. But 6 times 3 does not equal 8. So this one's going to be a no. So that's one way to do it. Another way to do it is to put our ratios in simplest form. So if I did 6/4, and I know I can divide both of those by 2, I get 3/2. But if I simplified 8/12, and I divided both of those by 4, I get 2/3. So no, our simplest forms are not the same. And then cross products is when things are multiplied on a diagonal. So we'll come back here. If I multiply on our diagonals and it's the same, that means it's proportional. So 4 times 8 equals 32. 12 times 6 equals 72. So those are 3 different ways of showing that these things are not proportional. All right. So I showed you a lot of different strategies for seeing if something is proportional if I have two ratios to compare. But if I'm comparing a whole table, the best way to do it is to look for what the multiplication or division pattern is, because that has to be consistent for the whole table in order for the table to show a proportional relationship. Now our table over here has some fractions in it as well, so we're going to start with our whole numbers looking for the multiplication pattern, and then we'll go back to the fractions to see if that pattern stays true. So here from x to y, 1 to 6, again we're looking for multiplication or division patterns in order for it to be proportional. Here it's times 6. 1 times 6 equals 6. So now we're going to go down to the next whole number. 2 times 6 equals 12. So that's true for the whole numbers, but we have to make sure on a table that it's true for every row or every column. So we have to look for that constant thing being multiplied. So it looks like it's going to be times 6. Let's double check for these other ones as well. Okay, 1/2 times 6/1, I'll cross cancel. 2 divided by 2 is 1. 6 divided by 2 is 3. 1 times 3 is 3. Okay, so that works. 3/2, if I did times 6/1 and I cross cancel, 2 divided by 2 is 1. 6 divided by 2 is 3. 3 times 3 is 9. So yes, this is going to be proportional. And that's because this pattern is true for the whole thing. If I do x times 6, I get my y value. So yes, it's proportional. You need more than just a yes or a no on your answers on these. You do need to show the work to support how you got your answer. All right, here are 5 problems to try on your own. So go ahead and pause the video, try these on your own. It's going to be a yes or a no, but you also should have some work with it. Okay, let's go ahead and check our answers. So here, if you see an easy multiplication pattern up and down or side to side, that's always a good place to start. I see one here on the top. 1 times 5 equals 5. And 2 times 5 equals 10. So number 1 is going to be a yes. All right. Number 2, I think I'm going to practice using the strategy of simplest form. So here, if I did 4 over 6 and I divided by 2 to get this to be simplest form, that looks like times, but it's really divided by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So in order for this one to be proportional, I also need to have it equal 2/3 in simplest form. So here I'll divide by 6 and 6. 18 divided by 6 is 3. 24 divided by 6 is 4. No, our simplest forms are not the same. So no, that doesn't work. All right, number 3, 10 over 3, 5 to 6. I think I'll use the strategy of cross products on this one, just to practice our different strategies. 6 times 10 is 60. 3 times 5 is 15. So our cross products are not the same. No, it's not proportional. And then let's see, 25 over 20 and 15 to 12. I don't see an easy multiplication pattern, and those numbers are pretty big to multiply with. So I'm going to do simplest form like I did on this one. So on this first ratio, I'm going to divide by 5. 25 divided by 5 is 5. 20 divided by 5 is 4. So that simplifies to 5/4. And then here, if I'm going to simplify, I would divide by 3. 15 divided by 3 is 5. 12 divided by 3 is 4. Here, our simplest form of those ratios is the same, so it's going to be a yes. All right, and then number 5, when we are looking for proportional relationships on a table, again, we're looking for that multiplication or division pattern like we did in number 1. So here, we're always looking from x to y. So from 1 to 12, that would be times 12. Let's see if it works for the other ones. 2 times 12 is 24. Yep, that's true. 4 times 12 is 48. Yep, that one's true. And then 6 times 12 is 72. Yes, that's true. Yes, our pattern is when you take your x number times 12, you get your y number. So yes, it's proportional. All right, our next key idea here is where they show you cross products. I actually showed it to you a little earlier because I think it's a useful strategy to know doing those first problems. But now we're going to look at ones where cross products is really the best strategy to use. So in our proportion, A is to B as C is to D. The products A times D, these guys that are in red, and B times C, these guys that are blue, are called cross products. And they're called cross products because they are diagonal from each other. And then they tell us the cross products property means the cross products of a proportion are equal. So if they multiply on the diagonals to give you the same number, then that means that those two ratios are proportional. All right, so let's take a look at a problem that we could use for cross products. So here's a story problem. It says you swim your first 4 laps in 2 4/10 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? Okay, so we are going to write our proportion here. 4 laps, 2.4 minutes. And then we're seeing when we did 16 laps, it was 12 minutes. Okay, so when you're lining up things in a proportional word problem, you do need to make sure your labels are in the same parts of your ratios. So here I put laps on the top and minutes on the bottom on the left side, so I had to do that on the right side as well. Okay, so let's go ahead and use cross products to see if these two ratios are proportional. So 4 times 12 is 48. And now I need to do 16 times 2 4/10. We're going to multiply it like 16 times 24, and then we'll put the decimal in at the end. 4 times 6 is 24. 4 times 1 is 4, plus 2 is 6. Cross that out, add a placeholder 0. 2 times 6 is 12. 2 times 1 is 2, plus 1 is 3. 4 plus 0 is 4. 6 plus 2 is 8. And then I've got my 3 here, so I have 384 it looks like, but I have 1 decimal in my problem, so I have 1 decimal in my answer. So my cross products here, they're going to equal 38 and 4/10. And no, my cross products were different. So no, my lapse is not proportional to my time. This one did have a multiplication pattern. So if you notice that 4 times 4 equals 16, but 2.4 times 4 doesn't equal 12. That's another way to do that problem. So it doesn't matter which strategy you use. We're just showing you different strategies so you can pick the one you like. All right, here's one to try on your own. Go ahead and pause the video and try this problem. All right, so let's go ahead and try it. So first 20 pages of a book in 25 minutes. So I'm going to do 20 pages in 25 minutes. My second ratio needs to be the same order. You read 36 pages in 45 minutes. Is the number of pages read proportional to your time? Okay, so let's see. I think I'm going to do the simplifying strategy on this one as well, because I don't see an easy multiplication number pattern here, and my numbers are, it's going to be a little time consuming to do cross products. So over here, 20 and 25 are both divisible by 5. 20 divided by 5 is 4. 25 divided by 5 is 5. So that means 4 pages for 5 minutes. And over here, 36 and 45 are both divisible by 9. So 36 divided by 9 is 4, and 45 divided by 9 is 5. So both of these rates simplify to 4 pages per 5 minutes. So yes, it is proportional. All right, so write an example of 2 ratios that are equal. Explain how you know. Write an example of 2 ratios that are not equal and explain how you know they're not equal. So go ahead and pause the video and try these 2 on your own. Okay, so let's go ahead. Obviously, your examples are going to be a little different than mine, but they should have an explanation to go along with it. So let's see. I will say 2 to the 4th, 2 over 4, and 3 over 6. And I know they are equivalent because they both simplify to 1/2. Here I would have to divide by 2. Here I would be dividing by 3. Okay, and then 2 ratios that are not equal and how you know they are not equal. So let's see, I'll do 2 over 3, and then I will do 1 over 8. And let's see, I'll show this one with cross products. 3 times 1 is 3, 2 times 8 is 16. And how do I know they're not? They have different cross products. You should have different ones than mine, but you should have some sort of explanation to go with it. All right, last one here. Go ahead and pause the video and finish this answer. All right, let's see. It says one way to decide if 6 hours for $4.80 is the same as 10 hours for $8 is, let's see. On this one, I think I would probably find a unit price. So if I did $4.80 for 6 hours, I would do 4.8 divided by 6, which would be 0.8, and money has 2 decimals. So that would be 80 cents per hour. And then for $8, 10 hours, let's see, 8 divided by 10. 10 does not go into 8. It does go into 88 times. So unit price here tells me that both is 80 cents per hour. You could have said something about cross products, write the ratios and find cross products. Could have said something about finding simplest form. So there are a lot of ways that you could explain it, but you should have some sort of explanation. And these two are going to be proportional.